जन गण मन अधिनायक जय हे, भारत संविधान भारत भाग्य विधाता। जम्मू कश्मीर पंजाब हिमाचल हरियाणा राजस्थान यूपी उत्तराखंड बिहार गुजरात मराठा द्राविड़ आंध्र तेलंगाना केरल कर्नाटका मध्य वंगा उछल जल्दी तिरंगा तब गंगा तावीव हिंद हिमाचल तावी यमुना गंगा सरस्वती कृष्णा ब्रह्मपुत्रा उछल जल्दी तिरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जयो गाथा भारत नागरिक भारत विधाता जनगण मंगल दायक जय हे भारत संविधान भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय भारत वंदे मातरम सुजलम सुफलम मलया शीतलम सहस्या श्यामलम मातरम वंदे मातरम जय भारत जय संविधान। Suraj Singh from Faridabad, NCR, Bharat. In routine of this episode of Daily Talk or Usual regarding profession of engineering, in construction, in design and in all. Engineering by profession is very high profile discipline field branch of engineering civil, which I belong to. Though I belong to branch civil, yet you have to deal with many other disciplines in part for purpose of coordination and for purpose of interface. That is all included in domain of project management. Management, what management disciplines, management domain thing, our management does not tally with that. What I understand by management, which people learn, is extract work from others and use it, and that is not our approach in engineering field. We put input everywhere. For every activity we put input in our disciplines, in our profession. Our profession of engineering is quite different. It is an outstanding profession which we could understand or we could not understand, but we have to act like this. If we cannot do outstandingly, we cannot achieve anything, any milestone. Engineering means deliver it. Engineering means understand, plan, do it, check it, and deliver it after reform. Engineering means something should be done. It should be seen done. It should deliver. It should work. It should perform. That is what is engineering. It's not alone theory. Theory is one thing. That is religion of engineering. But if you go further, application of that theory is very important. Without application, you cannot call yourself an engineer. If what you learn and it's not done, it's not carried out, then your learning equals zero. Equals zero. You mind it or you do not mind, the fact remains that. If you do not learn by practice what you are taught for, you cannot say that you have engineered something and that doing into shape whatever is actually through management of engineering, and that's why I consider engineering as a practical management domain where we realize our thoughts, we realize our feelings, we realize our designs, we realize contemplations for use of public of world. If you really understand engineering, you should be a very dynamic person. Dynamic mind, dynamic body, dynamic action, and dynamic results. You should have that privacy and personality. Your mind should work very dynamically for constructive purpose. If you cannot do that, there is no use of engineering education. Engineering education is quite different than all other educations because engineering is a domain where you start with even negative and zero. It's that domain where you create something in mind, hypothetically, speculatively, and then your mental scene should be translated onto paper and then onto ground. Engineering is that. Engineer itself is mind. Its meaning is mind. A genius means giant, and en means in. Engineer, in mind person. A person who has mind to think and to work. This is something extraordinary. It is something everybody cannot possess. It is something, if you think and do it, in fact, that is engineering, nothing else. And that is only for practical purpose. You have to deliver something that is useful, and that useful item is part of professional engineering. If your work is not useful, it's waste and it's not engineering, it's a piece of artifact or piece of art. Just like you make a picture of art and post on your wall, which gives no meaning at all, which gives no use at all. That is what engineering. Engineering has many disciplines nowadays, and most of them, majority of them are interrelated. Civil, electrical, mechanical, architecture, and few more. Few more are connected together as a part of wider family. You cannot use a building until it gets electrical supply, it's got mechanical supply. You cannot use that building. Similarly, it must have drainage system, water line system, and these days security system, information technology system, and so many others. That building means when you use this building, it doesn't mean you are just residing in building. This building serves you. There is a structure in that building which you try to understand. Building is a live body. It's a live mechanism. 24 hours, 7 days a week, it works. It does not stop. Stresses do exist in all members. Various types of loads, actions, stresses work there which we do not know. But we all take that into our considerations in design, in field, in approach to what we want to do. In fact, you can say we draw our x-rays, our plans ourselves according to needs, according to requirements, and then we shape them to reality. That is what engineering is. Means engineering is a stage which you can say you just imagine something, hypothecate something in your mind, and try what it should be, what shape it should be for certain purpose, and then bring that imagination onto paper and amend it and create something, and then practically think how to convert to physical being and do it, and then use it. This process is called engineering or engineering art, where engineering mechanism later on evolves. Then it's not simply that your university can put in your mind, or your university or college puts in the mind. No, they cannot put in the mind. In fact, they teach you in pieces something. They don't teach you in integral fashion. And in fact, when you come out of your university after having got through your degree, you're not clear what to do, what not to do. You are just in search of job, and that's a fact of life. Job is also important. The question is how to begin with engineering. Think and do, plan, think, plan, again think, plan, again think, and do. And do is very important. Up to planning, thinking it's okay. It's like poem. It's like 10 short stories. It's like something else. But when you want to do it practically, using natural materials, using your theoretical knowledge, using your practical knowledge, that stage is called engineering, and this applies to whole discipline. And that engineering processes, all processes, what we I'm saying, initiation, conception, production on paper, development of plans, further development, and bringing it to something that works, and then construction of that. All stage is engineering, and it involves engineering management, and that management is called project management. Project management definition is very, very vast. It cannot be controlled by one book or two books. This is different for every project. That is main point I want to inculcate into your mind, that do not take it similarly or to symmetrical way other professions do. Engineering profession of construction is very basic, very original. You start from scratch and deliver something done, built. So your job is completely different. Your job covers various stages, depending on what project it is. Means you start from very rough stage, very, very tedious stage, where you may not find and that location we want to plan even sometimes a glass of water. You have to move in forest or wood, in desert for survey. You have to spend your time there to pick up information. Even if you use GPS, it doesn't make a difference. Only thing, your activity will be faster, but principle behind that lies, that behind that is same, that you have to be involved in all processes, off sites, on site, in office, off office, in sun, in moon, in rain, in thunderstorm. There is no restriction, there is no definition, and that we should take into our consideration, because major part of this is undertaken by civil engineer. Civil engineer, remember, civil means for public. Civil means for public, for Nagrik, for human being all over world. So do not consider yourself just to sit in office and create everything. Not done, not possible. We have to analyze ourselves first. We have to analyze our professional requirement and then value ourselves. I don't need any value from others, because I take my value from my job, my activity, my work, even if I am not recognized. Getting recognition is not my criteria, it's not my time, it's not my schedule, it's not my destiny. My destiny is delivery of what is required by others. That is important. If I deliver successfully, I consider myself recognized. There will be defects, there will be everything, that's another part. But basics of engineering we have to understand. Our engineering is completely different from IT field. It's completely different from other engineering field. Our engineering starts from very basic ground, rough ground. Others engineering starts from within buildings. When we produce some building, then other guys comes, electrical guys, mechanical guys. They come in between also sometimes, but in general, majority of their work start when your building is working in construction, it's moving. Otherwise, they do not come until you have finished foundations. You are doing structure. Only at that time also they come, but all others come later on. This means you are going to extend some base to others. That is very important point. So you should draw actually pride from that rather being depressed that I got no recognition. From whom do you like to have recognition? From those who do not understand you? How can they recognize if they don't understand you? That's main point. Don't forget that whole city works because of efforts of civil engineers. You can see roads are there, buildings are there, metro is there, platforms are there, railways are there, airports are there, hospitals are there, every facility is there, and that is result of major part of civil engineering, construction engineering, architectural engineering. We have to keep this in mind before understanding what is management. This management is not business administration. This management is not simplified nuclear management. No, it is quite different management where practical aspect dominates. And that practical aspects means management of human being, management of material, management of equipment, management of time, management of, you can say, public dealing, management of statutory with the statutory bodies, and many other managements, management of quality, management of safety, management of environment, many other fields of course enter themselves when you work on this discipline, this profession of civil engineering. People may not even understand, but it is done. It is done. So I say we have to change our mindset. We have to keep in mind that we are doing 100% contribution from our profession to society, national society as well as world society. We cannot be thrown away. We cannot be dispensable. We people are solid people that extend, that incorporate our efforts with development activities throughout world. Go and see what GCC now is, what Middle East now is, and what it was before 50 years, 60 years, what we are now and what before we were. You can take example of Delhi, what it was before 30, 40 years and what shape it has got now. This is all because of development, not because of something. I have to draw pride from this development as an engineer. Though there would be some other substandard works, but on a gross way, it is public requirement, it is public system, it is public utility that we provide them. And that is where I stand. When we do engineering, when do we allow us for development, we have to pass through all phases, and we have to take every building, every facility as a project means there is something you have to deliver to society based on physical requirement, based on social requirement, based on industrial requirement, based on public requirement, and for whatever requirement that plan is, that project is, we have to do it and deliver it. When funds are provided, resources are provided. I am not saying that we have to provide resources ourselves. We have to serve those people whose resources are, whose demands are, whose requirements are. We have to fulfill them. That's major point we have to consider. I'm not saying we will do everything, but we will support everybody. For requirement of resources, we have to support. For requirement of quality, safety, project, feasibility of funds, budgeting, means all these sections required to be supported by us directly or indirectly, because computation of cost cannot be done until we provide our feedback. If we know quantification, if we know area of land required, if you know everything, availability of material, and suggest on that feasibility report or some other report, that prepares a ground for everybody to work out cost and what about feasibility, possibility or impossibility of that project. That's why I say we have to talk differently. We are not confined to project management education, but practical education that engineering equips every engineer with. You are all equipped. Public should know that. You cannot keep it free. Public should know that what you are. And you have to tell them when you have an opportunity to interact with public about this issue. Because public keeps off from these activities due to projects being controlled, confined, and inaccessible to general public. We are not working like other professionals, like doctors. Patient is accessible to doctor, like advocate. Client is aggrieved party is accessible to advocate. Similarly, people are accessible to courts. People are accessible to chartered accountants and to all others. But to ourselves, they have no direct link because they have nothing to take from us directly. Yes, they can use those projects to deliver, but otherwise they do not know anything about what you do behind scenes. People do not know, except engineering people, what we do in designs, what we do in sites, how we operate all these activities. People are not clear. That is sole purpose I wanted to talk to people as well as to ourselves, what we are, what people should know. If people know something, it's better. If they know anything, means they are kept in dark, and there are people who keep them under darkness. And these people are promoters, these people are industrialists, these people are contractors, these people are, you can say, whoever dealing with money and to make profit out of construction and real estate and other such projects. All those. They are not well informed, they are ill informed, and they talk that way. They abuse ourselves, and they help produce bad works or substandard works. So project management is something very different. It involves all resources, as I said, material, equipment, human resources, technology, engineering, and mental power, physical power. This profession involves. It involves market, it involves public, it involves governments, it involves so many attractions which give me a degree of pride that we are not an isolation. Our profession, our, you can say, disciplines are not in isolation. We are integrated with everyone, but we never identify that state in our profession. It's great to some extent if you analyze and think. Analysis is actually a formula that provides you with many informations. Analysis. Analysis is actually theory, a theory to understand each and every member of something. Analysis is something very intelligent study. If you can analyze some use, you analyze structures, I know. You analyze foundations, you analyze superstructures, and you analyze various forces. You are limited to that, but you have to analyze society, you have to analyze public, you have to analyze yourself, you have to analyze activity, you have to analyze your human resources. All these you require to analyze just to have complete analysis. And if you can do that, that's great. This analysis is your teacher. This analysis is your guide. This process of analysis shall teach you which way you have to adopt, which result you have to adopt. There will be negative considerations, there shall be positive considerations, there will be multiple considerations and division considerations. All considerations do exist there. You have to find best one for you or a combination of few for your purpose. That is where analysis is done. And when you find different answers, you have to synthesize them. Synthesis is opposite to analysis. Analyze and synthesize. That way you understand your system, you understand methodology of you are going to do, so that you convert that to better design, better approach, and better work which is expected of you scientifically, theoretically, engineering way. We have to provide that type of engineering services to our those people who are going to use or who are going to own that project. This philosophy shall not be given in books. You have to think yourself. Thinking is best one. If you think like this, you can create something. Thinking only in your calculations is not sometimes adequate. You have to think philosophically, and then once you think that no, I have a responsibility, because this analysis shall provide you with a power of analysis and responsibility. You have to analyze and apply that in job. That is very important. So I say in our activities, in our management system, project management on construction, on buildings, on project others, all those engineering spheres, like whatever it is, civil engineering is very widest field, very wide field. You are on every project. You may be on building, you may be on flyovers, you may be on roads, you may be on railway, you may be on sheds, you may be on metro, you may be on water line, you may be on sewer line, you may be in water resources, you may be on dam or canal or river. Wherever you find yourself are there. Hospitals, hotels, offices, which not, planning, on-site, and design, and quality, and safety, we are not. This means you have many directions in your life to move with, many directions. But what, what character, what quality engineer should have, that is first point. If you are not quality person, you cannot do engineering. Quality means you must have many personalities, many facets of your character, of your quality, your capability. Your capability power must move in a range from negative to very much positive. Why I said negative? Because negative is power. People say don't take negatively, don't think negatively. Those people are ignorant. All those who hate negativism, I do not understand them, because without negativism, you cannot understand what is positivism. Negative power. Actually, mathematics is negative. Calculations are negative. If you do not understand negative power, you cannot understand reality of life. Negative is actually positive management. If you just know mathematics, you must, if you know, you must have studied that minus is negative, minus, plus, and minus. If you add up two minuses, what is the result? You would say it is minus, minus 2 equal to minus 4. That is right. Means here you are adding up two minuses and value of minus is increasing but in negative direction. And if you add up 2 minus 1 plus 1, what shall you get? You say I get 0. This means you reach origin by using two negative and positive. You are getting a destination that is called 0. Now you multiply them. What you get? Minus 1 multiplied by minus 1. Shall you get answer what? You will get plus 1. This means if you use minus signs, if you use minus power or negative power in multiplication, you shall get a major power, and that is positive answer. Try to understand what I am saying. Multiplications of minus power together once is given answer in positive. Means if we are using minus power once in both digits, you are getting plus power. This means minus power also has power. And if you divide them, you have to see yourself what I am talking about. If there is no minus power, there would have been no micron. 10 to power minus 6 is micron. 1 over 10 to power 6, it is written. Or it can be written 10 to power minus 6. If there is no micron, currently we call micron, we use it on computers. There will be no computers. Think of what I'm saying. Minus world exists and it supports positive world. So minus thinking is very important for purpose of creation. You may call it imagination, but remember, imagination is only used for purpose of positive work. If there is no imagination, there is nothing. Imagination, in fact, is a dream. Dream you have to use for your positive work, and that is what I am saying. Your destination should be your own allotted dream, your dream of that project. Everybody dreams that I want such type of work. I wish I get this job. I wish I get that destiny in my life. This is all your images in your mind and you get it. So what I say, we have to deliver those images in our minds or in minds of others to reality, to practical world, to a physical shape. And this stays from imagination in our mind or imagination in other minds, in combination, covering all route from that to delivery of that physical shape is engineering, and its control is called management. Engineering management. If we grasp this, we can do wonders. We should not remain in isolation. We work in our field, in our way, in our discipline, but we should be in touch. We should be in coordination, in interface it with all others. That is direction of management, that you have to deal with others. If we can do that, that is better than nothing. That's better than everything. So I said in our field, we do designing. Before that so much, but let us start from designing. We deliver design. We deliver package of drawings, package of specifications, package of what is required to be done to someone else, or we do ourselves. We give it to someone else, and that someone else is side persons. Side person means engineer, side person means supervisor, side person means contracting company, side person means quality and safety and all that. We deliver that design to them. And these people work on that drawings, where based on those drawings, resources are collected, resources are procured, and resources are human resources, material resources, machinery resources, and other resources, preparatory resources, temporary resources, permanent resources, all those are included physically on those projects elements, and that is what is called work of management. We have to employ people, we have to employ machines, we have to procure materials, and all those in combination work on our engineering management. There involves so many. Design engineering is involved, bidding is involved, award is involved, tender and procurement is involved, quality is involved, safety is involved. So much is involved that one man, one person cannot do all that. That's right. But knowledge is a must. I said management rests on various pillars. Our management, building management, projects management, whatever project, it rests on many pillars, many columns. But 3 points are very important, and these points are time, cost, and quality. Time, cost, and quality. Time cannot be changed once you are fixed. If you change time, it will impact upon you. Time cannot be altered. If you alter time, it will alter financially and it will alter commercially. If you do not keep up on quality, you cannot deliver demanded material. So quality is having another type of power. It's the power of standards. It's the power of perfectness. You have to deliver something done perfect. Then is your cost. Cost means how much budget you are allotted to your work. That must be maintained within limits, or else you have a loss indirectly. Whatever profits you have earned out of that, you have to pay back from that if exit budget is there. If additional budget you have to spend. So these 3 points are supporting points, controlling points of your project activities, or you can say project management. Cost you have to control, then you have to control time, and you have to control quality. In addition to scope is defined, cannot be changed. Communication is a system, resources must be procured, criticalities must be checked. All those we have to maintain, but these three are controlling factors. If we control cost means you keep your project within budget. What budget you allotted, you have to keep that constraint under control, means cost control is a must. And then time does not wait for anybody. Remember, time is power. Time cannot be controlled by you, but either you control time or time shall control you. It's up to you to decide if you want to be controlled by time or you have to control time. If you can maintain time, you are a successful person. But it's not that easy activity. It's very different activity, very powerful activity. You have to struggle with time. That is time expectation. That is time's expectation. It forces you to struggle. Then quality. You may push for bad quality compromisingly, but quality knows very well. It knows it very well. Quality means perfection to some extent. Perfection means perfection to what you expected of that. It is not exactly defined, but relatively defined. Quality means what minimum demand You expect from something, definition is there of qualities mark, that definition must be achieved minimum. If you can maximize that or enhance that, that's welcome. But quality is not in itself, it is compared to something, some standard. And if you just add to that something else, some other power, then it is called better quality, enhanced quality, or value added quality. So these points of management, these three triangular points you may call them, are very significant. In addition to communication, communication is also very strong bones in this arrangement. Resources and planning, you can say cost control is also a part of planning. There are so many other factors. Scope cannot be changed, it is fixed. If it changes, then it affects all. It affects cost, it affects quality, it affects time, it affects everything. So this management that these points that I am trying to convince to you, try to discuss with you, these points are very important points. These are management pillars. These are management, you can say, controls itself. These points are very, very important. Projects must be clearly defined. Management must be clearly defined, explained, self-explained. It must be in speaking power. What work you have to do, you have to follow certain statements. Those statements may be on design, on drawings, within specifications, within management, or wherever, must be clearly spoken. Speaking in a sense not by tongue or mouth, but by concepts in writing. What is to be done should be clearly depicted. If you get that, you must have stamina to read that. If you cannot read, if you cannot understand, and if you cannot communicate, then you are not doing your job. This is very important for us, our fraternity, to be used to reading, to be used to writing, to be used to interacting. These, these marriage points are very significant. Otherwise, you cannot do work. Communication power is a, you can say, requirement in our profession of projects management. Good communication, reliable communication, in addition to scope and your 3 points I explained to you, and other resources and all that, risk factors and this and that, all act simultaneously from time to time during whole currency of project. We are talking of time, we are talking of quality, we are talking of cost. These three means supports our project. If there is no time, you cannot work. If there is no cost, you cannot work. So when these two parameters are failing, means you cannot even touch project. This means, for example, your budget of government or of nation, what does it give? It does give you a screened allotment of funds. Screened allotment, I mean to say, certain funds, whatever are given to whatever heads, are proportionately given depending upon total funds that you have to spend during that financial tenure. Same fundings is given to you as budget on that project. You say project budget. That funding, that allotment does not come from without calculations. It comes from hundreds and hundreds of items which are quantified and then valued. Those allotments are written on budget, and you have to stick to those fundings, those values, or else you will feel escalation of those items and project would slip from your control. It will be overrun in budget and you have no answer. You have no answer for accountability in that case. This point we have to understand explicitly if you want to make yourself a lead engineer, a reliable engineer, a reliable manager, because to my understanding, every engineer is a manager. There is a saying that an engineer can be a manager, but a manager cannot be an engineer. That is a fact of life. You are an engineer, you can manage. But if you are not an engineer, you are a manager, you can only use services done by others. You cannot do service yourself. Means you can extract others' work and deliver to someone else. You act as a management person who is a medium. When you are exclusively a manager, you are not a professional. You are just a medium to take work from this party or this person and deliver it to other person. You are a medium like post office because you miss your own say you are not an educated engineer. There you are limited. You may be a manager, but administratively, not technocrat. You are not technocrat. So you miss your status there. You cannot develop your thoughts. You cannot force your thoughts there because you don't understanding that. So what I mean to say, you have to evaluate yourself first. You have to identify, you have to understand your capacity. Keep apart your certificate. Think of your mind capacity. Think of your power, what you can think. You have to see your potential first. Then you have to see how much dynamic you are. How much power can you use at one time? That is very important. Your potential you have to know. And that potential keeps on increasing. It never decreases. That potential should be used in your activities, whether you work in designs or you work in official work or you work on sites. Official work is very important. In fact, official work is real engineering on papers. You have to take design, you have to understand design, then you have to quantify elements. I mean to say, whatever items are there, you have to enlist and quantify all those items. Then you have to see which material is best for you, which should be given. Then you have to understand mechanism behind every activity. You have to write every activity if possible. You have to write in form of construction or in form of quality controls or in form of safety controls. You have to convert your mind status, what you expect of that or what you want to do on site onto papers for others or for yourself, and that is called methodology of your all activities going to be performed. Those method statements would act boon for everyone who works there. Management cannot be defined simply in one statement. We are dealing with disciplinary managements. We are dealing with what? Just think on. We are dealing with drawing management or design management. We are dealing with bidding management. We are dealing with decision management of award. We are dealing with money management. We are dealing with construction management. We are dealing with, you can say, quality management, safety management. We are dealing with material management. We are dealing with machines management or equipment management. We are dealing with human resources management. We are dealing with marketing management. We are dealing with statutory management, procedural management. We are dealing with environment management. We deal with many interfaces on project. This is of course complicated, but essential to be done. Without doing this, you cannot deliver project. You have to analyze all this. When I am talking of this, I am just trying to project to you through my discussions that you have to think all that. Don't keep in isolation what you think. It's mine only. I am planning engineer. Why should I worry about design? Yes, you can think that way, but don't forget that you have to interact with everybody. You cannot plan if you don't understand drawing, understand design. You cannot plan if you don't know what time one activity takes on field. You cannot decide time management, then you cannot allow time to your activity. And then you should know quality also related to that activity, so that you can further develop that management of your time, because it costs. When you are going to fix time, you are going to fix cost. Cost is related to time. And when you are dealing with quality, from there you learn how much best it is, what time it would take, or whether or not it meets requirements of your contract or of your project. So these are all interlinked, and you have to take that into your mind while working on whatever project. It is easy if you understand well, or if you cannot understand this, it is very difficult. Very difficult. You should have an engineer's mind and not separate minds. I am planning, I am quality, I am design. Stop that thinking. That thinking does not solve your problem. Simply remember, you are an engineer. That's it. Engineer means developed mind, trained mind. You can use this power of mind in every domain of your field, every sphere of your field. If you do not do, you miss so much. Example, geology, called applied geology, which is science related to earth, related to lithosphere, and related to aerospace. But that is not mandatory, of course. Maybe it is mandatory somewhere, but engineer should know about this, particularly civil engineer. Oh, if you are a civil engineer and you are saying I am a structural engineer, very good. You are a civil engineer and a structural engineer. But you say I am not qualified geology, applied geology. Why did you not qualify? That is a question mark then. This means you are incomplete. You are not complete engineer. Geology means what is your ground, what is inside ground, what is earth, what is inside that. If you do not know that chapter of earth, that portion of your application of geology, how can you understand foundation? How can you understand formation mechanism? How can you understand what's inside earth? What is in soil strata? This means you have to depend upon others. In that way, means your design depends upon information provided by others, and you may not be able to understand that. Then this is a deficiency. Of course, it's a part of management, but you already missed that because it's not mine, it is yours. Without understanding ground reality, strata reality beneath your ground, where you are going to rest your foundation on, and if you do not understand that, you never qualified this. Even if you did not qualify, it doesn't make a difference. You have to understand now. Because education keeps on moving. Not necessary you learn from university, you learn yourself and do it. You are required to learn that. So you have to learn it so that you can correlate between soil parameters and your foundation. There are other subjects too, but this is related subject. There are optionals like water resources is optional, railway is optional, road bridges are optional, so many optionals are there. But where structure involvement is there, generally civil engineers call themselves a structural engineer. I don't know why. Structure is a part of civil engineering. This is very much true, very much fact. Well, management involves all engineers, in fact, not only civil engineers, electrical engineers, mechanical engineers, security engineers, and IT engineers. All are involved in project management at certain point of time, directly or indirectly. These are involved for whatever proportion of duration, whatever proportion of cost that could be. Everyone is required by mandate, by force, by requirement. This point, if you understand as sooner as possible, it will be better for everybody. So project management, composition of quality management and safety management and environment management and structural management and working management. This we have to understand clearly. Regarding safety, as I said, I have already talked in various videos of safety. I have put those URLs here on text of this video. You can refer to that. Those are very limited, of course, but provides enough information required to be known to civil engineer on projects. Those safety talks are there. I am now talking about quality system. Quality, as I said, is very wide term. Quality system or quality management. Quality management means management itself with quality. Management should have itself a quality, just like an engineer should have quality, just like a medico should have quality, and all other professionals should have certain quality mark. If I consider myself quality person, quality professional, I should work as well. Quality means how much money do you earn, that is not quality. How much work can you do according to meeting requirement, that is called quality. I have to produce quality management. I can say whatever management I conduct, it should be quality management. That is value. If you cannot do that, nothing, no use. No use at all. We should be clear. We should not shy. Quality management I have to do. Quality thinking I should have. Quality talk I should have. Quality writing I should have. Quality instruction I should have. I should give someone else. All these are quality, means management quality. When I say quality management, and also they say quality management, total quality management. What does it mean? Total quality management. It doesn't mean technical quality management. No, it means domain quality management. It means system quality management. It means gross quality management. That point we have to understand factually. Means whole system of that project, whole system of that proposal should have quality index. It should be based on total quality, which is management itself. Quality means Every activity should be accordingly, every material should be in accordance to requirement. Every resource procured onto site should be in accordance to requirement. Whatever human resources do we have should be in line to meeting requirement. Professionals or paraprofessionals, skilled or unskilled, whatever we do, we have should meet requirement. So I am saying we must have a system that complies with requirement. That requirement could be whatever standard system, it be ISO 9000 or it be something else. Whatever we adopt, that should be complied in through spirit, letters and spirit, keeping abreast limitations of human actions. We have to understand this point explicitly so that no degree of doubt remains left. No. Therefore, quality and quality control. We say quality, we are working with quality. Yes, I have designed something. I should claim that this is quality design, which means that design must have best use of application of what you think about. Best use that it will serve your demanded purpose. This design should comply with all codal requirements, land use requirement, your requirement, and this should give easy working on site. It should be designed in a way that it gives you satisfactory conversion from design to shape, physical shape. It should be constructible detailing. It should not be very questioning detailing. I have to explain that if I get a drawing from designer for purpose of implementation, purpose execution, and it states the EIFC issued for construction or by whatever else, there's a seal on that. You can use drawing for construction. This means that drawing should be perfect drawing. That drawing should contain every information I expect on site from design. If this drawing does not give me that information, I have to write again and again to designer, tell me what I have to do. That does not mean that it is quality design. Then it is just a design push, not quality design based on quality system. So as a whole, you say, when you start something and deliver that thing up to all those stages, whatever number of stages are there, all those stages should be based on quality impact, based on quality support, quality system application. That is what is called quality. Here we are following all process of quality management, and result which comes out of that must declare, must prove that this product is quality based product. If this product does not meet, if product does not state, does not claim that it is quality product, this means we have some lapse somewhere, and lapse is to be checked. Thorough scrutiny should be done. Complete checkup should be done where a mistake or error was caused. And if we find some error, then we have to understand what we have done. We have to reset it for future use. In that way, that we have to stop explaining what wrong was, but wrong should itself say either I am right now. That is what is management. If this system complete sequences are followed with compliance of requirement, without any impact on its products. That's called quality product. Means your quality product is providing consumer or customer whatever customer expects, or whatever you promise that customer, I'll give you this much, and in addition to that you are giving something else also. That something else is value to your payment. When it's giving you additional value, means it's giving you kind of bonus, that whatever you paid for, I am giving you back more than that for your benefit. It may be time benefit, it may be cost benefit, it may be quality benefit, or it may be something else. I am providing you this additional value free of cost. That is called value engineering. Value engineering. Remember, something you have to understand yourself. Nobody will teach you. Value engineering is not limited, it is unlimited. I am giving you better, something better, much better than you expected. You should be thankful that I am satisfying you. That is called super management. We are giving you something you did not demand, but because of our efficiency, because of our proficiency, because of our determination, because of your thinking power, because of your hard work, smart work, I am able to give you this additional benefit. That is where we have to manage. We have to manage so proficiently, so promptly, that we deliver something with having all control parameters successfully applied with, and bonus quality, value engineering. If suppose I say I will give you this project in 1 year, I'll get you delivery, and I deliver that one in 11 months. That saving of 1 month is a benefit to consumer, is benefit to customer. That 1 month additional use that person does, so some benefit goes to that person, and I am saving my time as well, because I can work somewhere else for that period. This is benefit to my customer and to myself. This is value. And this means I learn how to save time in future. So it will apply to those projects which are coming up. Or I can save money. This was time factor. I can save money from my budget by my hard work and use that money for some other good material for that person, which is super one than I promised. Same way, I can extend benefit to my customer, to my client. That should be criteria behind our project management. If there is no such extraction of benefits from management, then that management is dead management. That management is not improving management. That management is old, obsolete management. If engineering thinking is not applied within management, that management is useless management. You are an engineer. You must use your mind of engineering for delivering project in a best way of management. That is what I try to explain to you, because if you go through PMP books, you will not find such information anywhere. Because such information comes by experience only, not by tutorials or from some authored books. Those authors have limitations because those authors are not prone to exposure of sites, to exposures of technology. Management are two types. One is use others and use yourself. Then I am giving jobs to someone, do it, give me back, and I'll sell it. That is one management where you are a dealer. So I don't want dealer experience, dealer management. I want practical management, professional management, in which management you do not depend upon others exclusively, but on your own thinking, own efforts. You use others as source to support you, not to dictate you. And that way you use your mind fully for production of something. You are using your mind, you are using your efforts, you are using your technology, you are doing method statement, and then delivering something. That is live management, that is technological management, that is project management. This is not dealership management, this is professional management. I am not dealer in that case. I am service provider, I am material provider, I am product provider, I am manufacturer. You can say that party wanted something, I manufacture that and deliver it. You have to keep this in mind. Professional management differs from dealership management. When we say we are managers, this means you are engineer first and then managers. Because you know engineering, you know pluses and minuses of everything, every activity. You know what is life of that activity. You know what is procedure of that activity. You know what is technology background behind, and then you carry it out. That is product based on quality system, and that product, when it performs, it can say, it can claim that it is quality product. It a product that performs, this means that this product is reliable, which means this product is safe, shall provide safe service and durability. Safe product, safe service, safe life, which was required of it. Reliability. So I should also be reliable as an engineer, and every engineer should be reliable. If you are that, you can manage project. Management of project, I was talking about ISO 9001 2015. We usually do, often we use it, because Sigma 6 does not suit construction engineering. Reason: 3.5 permissible errors. And if you do 1 million applications or 1 million products in construction engineering, this doesn't value. We do not take it that way, we take it different way. That whatever 2015 speaks, we used to do it long back. We used to do it long back. But now terms have come, definitions have come, and explanations have come. So we are using ISO 9001 2015. And up to that, before we used 2008 to ISO 9001 2008, which has become obsolete now. Now in run is ISO 9001 2015, which is a complete reshape to 2008. What major changes are, I have explained before, just I repeat. That first, do not be strict on documents. Documents are very important. You cannot move without, but there are choices. There are choices left to you. One choice is mandate of documents, which must be there, and that is related to Annex SL, High Structural Language of Project Management, Quality Management. And then second one, option. There are options that you have these details in documents form for yourself. not for international standards. That second approach is yours. That is also very important for purpose of your project, to exhibit, to express, to evidence that you did that, achieve that, for purpose of quality implementation. This means two layers now. One is mandated layer by international standards, and other one is your company standards or your own standards. But if you have those second layer too, this is not mandated, remember. You should have record of that also for purpose of establishing that you complied with this system. That can be any number of documents. That's up to you. What is your company? What is your organization? What is your scope? In which direction you are going? What sort of projects you are dealing? What sort of activities you have? It depends upon all the what size of your company, how many people you have, what power you have. It depends upon those. But it is documented information. It's not system of documents. There is a difference. This information has been entitled documented information, which information is available for your own sake and in future for purpose of reference. Or you may say resources of your company, your organization. That is called documented information, not system of documents. System of documents is one, layer one. That is a mandatory requirement. That is in Annex SL. First, I will repeat what is Annex SL. Basically, it is not very different than something else. It is very clear that they want a system. They want written system. ISO 9001 2015 demands you to have a minimum requirement for your organization, and that requirement is mandatory if you are practicing quality system under ISO. You have to conform to that in Annex SL format. And others, you have your limitations, you have your control yourself. Only for reference, these auditors when come to you, when survey your, they scrutinize your practices, they may require, they may not require, they may say, okay, show me this one, I have to ensure that you are doing this one. But this phase one, or you can say layer one, is mandatory. No way you can escape or avoid it. That is what I am trying to explain, and Annex SL stands for that. There are 10 clauses in that. Those clauses give certain indications. Those clauses require certain minimum standards, minimum explanations, and those you have to put in those clauses, and that is called declaration of your quality management system and format Annex SL. If you describe that and practice that, you are complying with ISO requirement. It's big consideration. This was one point I explained to you about what is required. Another point is, in previous one, 2008, there was some low profile management description, means responsibility and liability were left to lower profile managers, inspectors. They were left with responsibilities, and top management and heads were relieved of that. But now it has changed. Every top person is held responsible and accountable for whatever results do come, for whatever you can say liabilities come, they are all liable, and this is a great change. Previously, I am MD, I am chairman, I am not responsible this quality management. Let engineer take care of this, let that inspector take care of this. This excuse would not work now. Would not work. This excuse would not work at all. Here you are bound. Here, because you are owners of this organization, you are administrator or chairman of this organization, it is your responsibility to keep all site equipped with whatever demands they have, requisitions they have, your responsibility, your direct involvement. And if you do not do that, you are running off ISO 9001 applications, means you are violating these rules, then your certificate can be at stake. That is what it is. Let me now revive it for yourself, because it is very important. And every day I try to tell you something about that, but it is very important. What it says, I'll read it for you, because without that, talk is unclear and not acceptable. It says an organization, what is system actually is talking about? It's talking about an organization which adopts a management system to take care of comfortably achieving its set objectives, which is very clear term. Management system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which leads to enhanced use of resources, improvement on risk management, and increased customer satisfaction by meeting product or services expectations. Organizations do work on various management systems by quality management, environment management, safety management. These are names, etc. Also there. These various systems in line to ISO 9001, 2008 used to work on varying management structures causing inconvenience to interface with each other. Annex SL, which I am talking about, being a high-level management system, has produced a common platform so as all systems that organization adopts can be drawn based on Annex SL designs or format. Such arrangement provides many commonalities in designing system, implementation, monitoring, evaluation, and improvement by trying to eliminate conflicts that existed within ISO 9001-2008 system. All management systems shall have single high-level identical core text with common terms and definitions. High-level structure cannot be changed, but discipline-specific subclasses can be both added or changed. Annex SO applies to all management system standards, publicly available specifications, and technical specifications. Revised ISO 9001, 14001, and 45001 shall all be based on Annex SL high-level structure. Now I am just going to brief about structure of SL, Annex SL. As it gives, there are 3 columns in that. Column number 1 says clause number, column number mandates format title, and then next column which says description and intended action related to PDCA. We have to define in this actions, what we want to do in relation to PDCA, which means plan, do, check, act. PDCA means PDCA itself is management abbreviation. P means plan something, we are planning, we are designing, we are doing everything. Do it means we are doing that, of course, in designs as well as on site. Check it means we have to test it. A, act. If there is something, you do it, correct it. This is called PDCA. Now come on to next. Let us say clause 1, it's regarding scope. And this says intended outcome of management system which are industry specific and should be aligned with clause 4, context of organization. Then clause 2, which is normative references, which includes the details of references, standards or publications relevant to particular standard. So these are two. One is scope, other one is normative references. Number 3 clause is terms and definitions, means detailed terms and definitions applicable to particular specific standard in addition to format related terms and conditions. This is detailed terms and definitions applicable to particular or specific standard in addition to format related terms and conditions. So class 3 is terms and so class 1 scope, class 2 normative references, class 3 terms and definitions, and then class 4 is context of organization, which includes understanding organization and its context and understanding needs and expectations of parties, determining scope of management system and management system. This is context of organization, where you have to understand organization, you have to understand its context, then you have to understand what are needs there and what do parties expect organizations to deliver. Then scope of management to be determined, and this is management system, that is context of organization, which is an exclusive and reliable point which you have to understand and define, because this shall speak of you what you are going to do with all controls. This is context of organization. Then clause 5 comes for leadership, and it means leadership and commitment. Commitment is very important, remember, if you want to be good leader. If you say, I do not worry about commitment, then you are not a leader. You are a trailer. Then you say policy. This is a part of leadership. Then organization roles, responsibilities, and authorities. These are all part of leadership. Leadership demand, leadership, you can say, controls, and leadership commands. Now, clause, this was 5. So number 1 is scope, number 2 normative references, number 3 terms and conditions, number 4 tech context of organization, number 5 is leadership, number 6 is planning, which says actions to address risks and opportunities. Actions to address risks and opportunities, and management system objectives and planning to achieve those objectives, that is in planning. And then the clause 7, which is support. Support to what? Support to project. Resources means many resources. We have written here only resources. It is human resource, it is material resource, it is equipment resource, or technological resource, or whatever resource you have, you can procure. For this, you have to keep with you. That is called support. Also, competence. Competence means capability. What capability or what consistency means capacity building as an organization do you have? What awareness do you have about what you are going to do? And what sort of communication system do you have? And what is documented information? All these are part of support from highest level and from lowest level, and from all these levels. This is called support. So resources unlimited, competency required, and awareness, yes, short sleep, must know, and communication. Every information should be known to everybody, every person, if possible, to an extent that they are called support. And then communication and documented information. Then we go to clause 8, which is operation, means whatever you are going to do in that, it's called operation, which includes operational planning and control. Operational planning and control means practical activities. It includes points for considerations are in-house process, outsourced process or ex-house process. Overall process management includes adequate criteria to control these processes, manage planned and unintended changes. Then clause 9, performance evaluation. Whatever you have done, it has to be valued, which includes monitoring, measurement, analysis and evaluation. Monitoring, measurement, analysis and evaluation, and internal audit and management review. This is regarding performance evaluation 9. And clause 10 is improvement. Non-conformities are there. Corrective action must be there. Continual improvement must be there, which is basics of Sigma 6 as well as 9000. Continual improvement must be there. So let us repeat. Clause 10 is improvement. Clause 9 is performance evaluation. Clause 8 is operation. Clause 7 is support. Clause 6 is planning. And clause 5 is leadership. Clause 4 is context of organization. Clause 3 terms and conditions. Clause 2 normative references. Clause 1 is scope. So we can just repeat that. Clause 1 is scope, clause 2 is normative references, clause 3 is terms and conditions, clause 4 is context of organization, clause 5 is leadership, and clause 6 is planning, clause 7 is support, and clause 8 is operation, clause 9 is performance evaluation, clause 10 is improvement. These are, and it says there are two important objectives in relation of ISO 9000. As I explained before, it says this standard should have been to develop a simplified set of standards that shall be equally applicable to small as well as medium size and medium large organization, and for amount and details of documentation required to be more relevant to desired results of organization process activities. This is what we discussed before. And now let's say ISO 9001-2015 quality management system requirements has achieved these objectives, and purpose of this writing is to explain intent of NEMA standards with specific regard to document information. So it says that this system is little different because ISO 9001-2015 allows an organization flexibility in way if it chooses to document its quality management system. This enables each individual organization to determine correct amount of documented information required in order to demonstrate effective planning, operation and control of its processes with implementation and continual improvement or effectiveness of QMS. So it is stressed that ISO 9001 requires documented quality management system and not a system of documents. So what is documented information? Definition references says documented information was introduced as part of common high-level language, common high-level structure, and common terms for management system standards. Definition of documented information can be found in other way. Document information can be used to communicate a message, provide evidence of what was planned as actually been done for knowledge sharing. Now, following are some main objectives of an organization. Let's now documented information. I quickly speak because this I have spoken many times. I always trying just I'll not explain this one. Let me have this drop of water. And first we Communication information as a tool for information transmission and communication. Type and extent of document information shall depend upon nature of organization's products and processes, degree of formality of communication systems, and level of communication skills within organization and organizational culture. Evidence of a conformity, provision of evidence that what was planned has actually been done. Knowledge sharing and to disseminate and preserve organizations' experiences. A typical example is technical specification, let us say technical specification, which can be used as a basis for design and development of new product or new service. So this information which we have could be on paper, this could be on magnetic equipment or electronic or optical computer disk or photograph or mothership or else whatever, can also be videos nowadays. So now what documents actually it says ISO 9000 and 2015 documentation requirement. It says quality management system and its processes requires an organization to maintain documented information to an extent necessary to support operation of processes and certain documented information to an extent necessary to have confidence that processes are being carried out as planned. Generally, we explain quality management system documentation shall include first type documented information required by international standards as I expressed before, and documented information determined by the organization as being necessary for effectiveness of quality management system. So now this clause, after this clause, make it clear that extent of QMS documented information can differ from one organization to another one. Because of size of organization and type of activities, processes, products and services, and complexities of processes and their interactions, and competence of persons. These 3 points are these which we have to think. Is it depends upon what size we have in our company, organization, what activities are we performing, what processes we are adopting, what products we are delivering, and what sort of services we are delivering, complexity of processes and their interactions also, and competence of persons who are involved on that project. So this documented information is, this needs to be maintained by organizations for purposes of establishing QMS. If you are saying we are applying with QMS, this information should be, which includes what is the scope of quality management system, what is documented information necessary to support operations of processes, and quality policy, quality objectives. Documented information is subject to requirements of. Well, now There will be many types of document. I'm just giving a reference, a list of that for information only. And this is documented information maintained by organization for purpose of communicating information necessary for organization to operate low-level specific documents. Although ISO 9001 2015 does not specifically require any of them, examples of documents that can add value to QMS may include. Now it says number one, like organization chart. Number two, process maps, so flows, process flow charts, and process description. Then number three, procedures, technical and administrative. Number four is work and or test instruction, IFC, etc. And then five, specifications, project specification, journal specification, particular specification, and then documents containing internal communications, memos, mails, methods. Then production schedules are descriptive schedules. An approved supplier list is list of all vendors. The test and inspection plans is called test and inspection plans checklist and ITPs. And there's a quality plan, site or project based documents, and quality manual, organization based documents, and then strategic plans, then forms. When it exists, all such documents and information is also subject to requirements of the clause. So documented information need to be retained by organization for purpose of providing evidence of results achieved records. So this could be documented information to an extent necessary to have confidence that processes are being carried out as planned. Evidence of fitness for purpose of monitoring and measuring resources, the evidence of basis used for calibration of monitoring and measurement resources. Measurement resources when no international and national standards exist. Evidence of competence of persons doing work under control of organization that affects performance and effectiveness of QMS. And then result of review and new requirement for products and services. And records needed to demonstrate that designs and development requirements have been met. Records of design and development input, and records of activities of design and development controls, and records of design and development outputs. Design and development changes, including result of review and authorization of changes and necessary actions. Records of evaluation, selection, monitoring, and performance, and re-evaluation of external providers and any other actions arising from these activities. Evidence of unique identification of outputs when traceability is a requirement. Records of property of customer external provider that's lost, damaged, or otherwise found to be unsuitable for use and of its communication to honor clauses, to honor. Now, result of review of changes for production or service provisions, persons authorizing changes and necessary actions taken. The records of authorized release of products and services for delivery to customer, including acceptance criteria, reference, and traceability to authorized persons. Then records of non-conformity actions taken, records of non-conformity NCRs, action taken, concessions, and record records of non-conformities, actions taken, concessions obtained, and identification of authority deciding actions in respect of non-conformities, results of evaluation of performance and effectiveness of QMS, evidence of implementation of audit program and audit results, evidence of results of management review, evidence of nature of non-conformities, and any subsequent actions taken, results of any corrective action. Organizations are free to develop other records that may be needed to determine conformity of their processes, products, services, and quality management system. Where they exist, all such records are also subject to requirement clause. So we have gone through here 10 clauses, and these clauses are in fact very important. This is, you can say, if we go through this, number one is scope, number two is normative references, number two is terms and conditions, number four is context of organization, number five is leadership, number six is planning, and number seven is support, number 8 is operation, number 9 is performance evaluation, and number 10 is improvement. This is what is annex about it. We will move further to the other one, and that's very important to understood that we close this file. I'll move to file, other one file, and that is this one. This is which I was continuing other day, and that is ISO 9001 2015 Annex SL, which is meant for company. Specifically, I authored this documents of company plus EPC contracting facilities, buildings, construction template, and that is what means two issues are the one is facility and one is a part of building, a part of facility that's buildings, because every facility has buildings. This I was talking about, and I have gone through this long document. I explained about this what it is, and this is because it's a question of plants facilities construction. I'll just repeat before going further details. It says an organization adopts a management system to take care of comfortably achieving its sets objectives. Let me stand it better so that you can get it fine, and I don't feel drowsy as well. I'll just take it this way, stand up and talk to you in the better way. Little stretching of legs also required. What it says, we have to take that into our consideration. And yes, I'm just briefing beginning of this document. I'll jump over to last point where I left. And organize this is regarding EPC contracting facilities, means for certain plants, big plants where buildings are also involved. It says an organization adopts management system to take care of comfortably achieving its set objectives, which being in this case winning from certain plant promoting company and EPC contracting for facilities and related buildings construction. Now, management system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increased customer company satisfaction by meeting product or services expectations. I repeat, this is very important one. Management system comprises various sets of procedures for charting out and implementing various operations or activities such so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increased customer or company satisfaction by meeting product or services expectations. In this case, product is EPC contracting facility. Product is facility plus building construction for certain plant facility. Which facility being promoted for implementing patented technology through defined chemical processes on plants producing required products. Organizations do work on various management systems, say quality management, environment management, safety management, security management, etc. All such systems apply in this case directly as well as indirectly. These various systems in line to ISO 9001-2008 used to work on varying management structures, causing inconvenience to interface with each other, but now all these issues shall be dealt with as framed in a common template. NXSL being a high-level management system structure has produced a common platform so as all systems that organizations adopt can be drawn based on NXSL designs or format containing 10 clauses, clause 1 to 10, which I explained before. This includes scope, normative references, terms and conditions, context of organization, leadership, planning, support, operations, and at end. Number 10, improvement. This is NXSL. Again, I repeat, clause number 1, scope, clause number 2, normative references, clause number 3, terms and conditions, clause number 4 is context of organization, clause number 5 is leadership, clause number 6 is planning, clause number 7 is supports, clause number 8 is operation, clause number 9 is, you can say, check, review everything, or then improvement, continuous like that. We'll take up that. Then EPC contracting facility, I said NXSL being a high-level management system structure has produced a common platform so as all systems that organization adopts can be drawn based on NXSL designs and format. EPC building contracting facilities and buildings construction can be easily defined within NXSL format. In this case, intentionally, both promoting company and EPC contractor managements have been tried to be included on one NXSL format only for purpose of clarity to understand real working on such projects. Though practically both promoting company and EPC contractor adopt their respective system separately, such management provides many commonalities in design system. Implementation, monitoring, evaluation, and improvement by trying to eliminate conflicts that existed within ISO 9001-2008 system. Various stages related EPC, contracting facilities, buildings construction can be covered within this NXSL template successfully. All management systems shall have single high-level identical core text with common terms and definitions which can be defined within NXSL. High-level structure cannot be changed, but discipline-specific subclasses can be both added or changed. As such, additions may be made where required related to EPC contracting facilities and building construction. NXSL applies to all management systems standards, publicly available specifications and technical specifications, as well as customized requirement. Revised ISO 9001, 14001, 45001, etc. shall all be based on NXSL high-level structure. Where related to in this case, though not included herein. This NXSL template shows below is only for indicative guidance to apprise an engineer how new system adopted by ISO effective September 2015 work to produce organizational prime quality document which shall govern whole organization quality process required by business, adding accountability shareable by business and technocrats leaders. Wherever and whatever requirements demand, items can be added, or as such items can be added as sub clauses, but no deletions can be made. Purpose of this template is just to project quality track quality track demanded by ISO 9001-2015 systems, which is a mandate published by ISO and without which applications, all existing ISO 9001-2008 registered certifications shall stand invalid after 3 years of September 2015. This means in September 2018, 2008 has gone. Therefore, this Annex SL adoption is a must for new quality system operating globally. In this Annex SL company EPC contracting facilities, I have already discussed clause 1, that was long discussed. I have discussed clause 2. I am just moving further so that we can reach our point where we left it. I'll continue from there because let me reach there first. I think it's somewhere 45 or something. Let me see what page number it was. Let me see what page number it was and how it can operate now. I think we had gone up to page. Which page is this? This is page number 50. As we had taken up this page 50. Risks we have to consider. Then I am going further down. Risk we have covered up. Then I had gone to support. I think I was working on supports. I remember I was working on support. Yes, in that I had gone through supports and I had talked about competencies. Yes, I think operations we should talk of, or supports I have to take. Let me just briefly define supports once again so that we can overlap our talk today. Just briefly, I will not just give details of that. I'll start with supports now. Actually, what is clause 7 in this? Clause 7 mandates for support, or something should be required before. Let me check it. Arbitration is there, we have talked of, and participants, okay. Well, then contract conditions. All right, supports we'll start with. What supports? Clause 7 support. What it says? It says resources, competence, awareness, communication, documented information, and points for considerations are material equipment and human resources. Let me do it clock. Material equipment and human resources, capacity potential of organizations and individuals, qualification of personnel, awareness among all pertinent system and its functioning, written job description, work procedure, safety procedures, quality control procedures, administration methods, etc. Then documented information is different than documentations. Whatever information about management and procedures or process in whatever form, such as written, text, maps, charts, designs, successful implementation, evidence of compliance of requirements, etc. No system of documents but evidentiary available documents for reference and future use, documented information. Now we'll see in details. Support for company promoting facility. This is what I'm talking of. I am speaking this about support. Support for a company Support for a company promoting facility project is drawn from state or nation or from public. Means it can be anything. It can be from where source. State has to decide. State has to decide about project plan and provide continuous funding on an yearly basis so that project is delivered to state in defined time. Internationally, support is required from companies, all overseas partners, and associates who are equal stakeholders within company's management board. Company requires in-depth engineering support from various competent and authentic sources. Company requires supports for land acquisition and its immediate development. Company requires paid support from its contractors in all dedicated and devoted commitment for successful delivery of built and performing project. Support for a prime contracting organization means many types of project activities conducted both from its corporate or head office as well as from site office and also from its other infrastructural facilities such as its maintenance yard, which be a centralized location to serve all buildings and other projects from it. Support is classified into human resources, mechanical resources, professional management resources, knowledge dissemination resource, communication procurement management, safety management, quality management, infrastructural financing resources, etc. Support resources acquired by construction organizations depend on type and working nature of organization, which is the current case is energy services contractor organization. In this case, organization is an EPC energy services and buildings specialist contractor who would require support resources related to its different ingredients and total requirement, which commences from initial designs to delivery of project as a whole or as a part as contract agreement demands. Contracting organization may be a prime general contracting or maybe only a small or medium level contractor who would require support resources accordingly. Degree of competence is very significant for required support resources, which would be required depending upon type of support resource. Degree of competence means educational qualification plus professional experience and consistency of experience with updated knowledge. Degree of competence also means trade qualifications plus professional experience and consistency of experience with continued development of practical knowledge, and this also means experience and knowledge based on maturity and work advancement to be conducted independently, and also means complete understanding of work applications with all kinds of technical and equipment support with decades of field experience. And also it varies from person to person, since professional engineer is supposed to have engineering discipline competency in designs or in the execution of projects construction, while a tradesperson would be different, required to have competency related to trade operations only. A general foreman shall be required to have specialist knowledge related to his area of work responsibility, while a foreman associated with general foreman would be required to work on lower areas but with full command on related operations independently. A division leader would be expected to have an engineering professional degree with long years of experience with multidisciplinary knowledge for working and application purpose based on interface and intercoordination. A quality division leader would be required to have engineering professional degree with complete backup of code provisions, specifications, working procedures, testing and inspection, in-depth knowledge so that all ITPs, checklist and method statements can be produced meeting trade and project requirements. An estimation division leader would be required to have a professional engineering degree with many years of estimation evaluation experience with complete backup of item rates, procurement prices, required technicalities of various types of materials and equipment with high degree of quantity serving practical and power of negotiations. Practice and power of negotiation. A complete understanding of construction contracts with FIDIC or NEC-based formats must be known to such leaders who must have detailed knowledge of contracts and arbitration. A procurement division leader must be thorough in material engineering for purpose of screening and charting out quotations, analysis, and operational research over that. A planning and scheduling division leader must be a professional engineer with thorough knowledge of engineering and prosecution methods with sequence of operations and applications required time for each operation. A planning engineer must have attained status to understand risks and risk resolutions, or else such an engineer would not be able to respond to risks, leading to keep area of concerns unforeseen. Similarly, a site leader must have all engineering requirements with decades of experience and skills to check, review, and chart out site issues efficiently due to the fact that site leader represents organization on front of project, who therefore must be extended or demanded support from other corporate leaders. It is a major requirement that all leaders must be fully aware about project requirements and about systems applications, while in turn must train juniors to keep complete required understanding to an extent job responsibilities demands. All leaders and associates must keep update on system requirements as well as whatever changes are brought into system management structure from time to time throughout currency of project. If so required, related training to all personnel should be imparted to keep them refreshed, just as training regarding safety discipline is imparted regularly. Suggestions should be invited from all personnel without any hesitation, so that what works in mind of personnel be exposed, and if good, should be included within system. Every organization is owner of many resources such as heavy equipment, backing plants, concrete pumps, concrete transporting trucks, electrical equipment, middle level equipment, as well as various others. All major size organizations do own many equipment for their own projects, drawing benefits on their investments due to the fact that they do not need hire all such machines, while they are free to rent them to other organizations. Organizations owning various heavy equipments are generally considered having better work potential and favored during bids consistency and comparison stages. All supporting items must be supported by documentary evidences, and formally a list of such supporting resources should be ready and attached with bid strength. All such supporting resources list should be updated all time and presented for examination and inspection if so required by owner and engineer to ensure that provided information is authentic and that contractors' assurance that such resources should be available during scheduled construction period. On similar pattern, list of human resources and subcontracting details must be provided and demonstrated if so demanded by engineer for verification. Many equipment that could be presented on list being on tower crane, wire cranes, shovels, excavators, rock breakers, concrete pumps, trucks and dumpers, winches, concrete mixers. Now, clause 8. Clause 8. Operation includes operational planning and control. Points for considerations are in-house process, outsourced process. Overall process management includes adequate criteria to control these processes, manage planned and unintended changes. And if we consider like this, it is company preparation of bid documents to be issued to bidder. This is just detailing. says company preparation of bid documents to be issued to bidder. Company is responsible to prepare all bid related documents that are required to be based on EPC bids. These documents comprises pre-bid, pre-feed, feed, scheme, designs, drawings. These documents comprises these documents comprise pre-feed, feed, schematic, designs, drawings, all disciplines, requirements and specifications, and list of all codes that apply to project. Contract form is also designed designed in its proposed format, which comprises of lump sum price for whole project or part of a project, various forms for bonds such as tender bond, performance security bond, description of project time, damage for delays, damage for performance failure. Just a minute, please. Just a minute. Sorry. Sorry, there's a problem electrical. Well, it's okay. Let me continue. Formats for contract form is also designed in its proposed format, which comprises of lump sum price for whole project or part of a project, various forms for bonds such as tender bond, performance security bond, description of project time, damages for delays, damages for performance failure. Formats for key personnel to be proposed by prime contractor from leaders to key personnel related to all divisions involved on project. Formats for equipment schedule bidder contractor intends to use on project. Formats for execution statement bidder contractor charts. Bidder or contractor charts is a strategy of project prosecution provided with all required supports such as human resources, workforce, equipment, material procurements, S-curve, cash flow through project execution, currency, and various other similar details. Bill of quantities BOQ duly filled up in all respects by bidder contractor for purpose of guidance only, which lump sum indicated on BOQ to be binding on bidder and contractor. Bill of quantities are prepared for each and every structure or foundation of equipment individually so that certain deletions or additions could be managed without any issues. Formats for list of materials bidder contractor proposes to procure from. Format for list of equipment and vessels bidder contractor proposes to procure from. List of all rates of materials and workers per day chargeable if so required to be developed for company by bidder contractor. Now EPC bidder contractor. Bidder receives all bid documents. What actually process? I'm just going to explain. Bidder receives all bid documents and analyzes each and every aspect contained within bid. Charter is opened and all details are entered for detailed discussion and brainstorming. The scope involved on project is studied and assessed with capacity of bidder. Assessment of approximate bid cost is made based on major quantities of materials involved and type and number of vessels and equipment involved. Assessment is made on suitability of bid and project execution period, keeping in view current project ongoing in organization. Bidder reaches a decision whether or not to do bid submission or to return bid documents with regrets due to being overloaded. In general, experience confirms that major bids are accepted major bids are accepted by bidder for submission so that reputation of organization is made up. Charter is continued by board with required declaration. Work on bids working out for pricing commences with. Complying with due processes, bids are worked out in details by estimation division, supported in all respects by all other divisions. Bids is processed in two volumes, one being technical bid and other being commercial bid, with both having different formats and sequence orders. Technical bid contains all details related to engineering and technical activities, while pricing related parts are included within commercial bid package submission. Bid work is always supported by external vendors from whom bid pricing related to their discipline is invited. Whenever necessary, clarifications are obtained from company required regarding whatever unclear issues. Once all details have been collected from market as well as from in-house working, all details and data are conferred in bid meeting internally so that final work on bid starts. Final price is decided by leader of bid organization, keeping abreast expected profits or lower profits so that a competition is created with other bidders. Final price is entered in required bid page. An alternative bid also is presented if so demanded by company or if proposed by bidder. All bid documents prepared by estimation team is finally compiled in a professional, orderly manner, and estimation leader closes tender for submission or bid for submission to company on or before a bid closure appointment hour and day. Company receives bid. Now what company receives it does? Then we have to see the company opens and scrutinizes received bid and commences with negotiations with lowered pricing index, lowest pricing bidder. Company opens technical bid and goes through all details whether or not complying with bid requirements. Report is prepared by company to ensure degree of conformity with bid requirements. Then after being satisfied by technical bid, commercial bid is opened and ensured its conformance to bid condition. Bidder is called for bid negotiations. Company, prime contractor negotiations. Upon scrutiny of bids, company calls bidder for various clarifications and confirmation that bidder complied with bid provisions while no deviations from contract and specifications would be acceptable to company. Bidder submits all clarifications pertinent availability of material and equipment with confirmation that all materials involved have been based on current and valid quotations received from vendor. Company may require demonstration about bidder's execution program and may like to ensure that all risks have been considered by bidder during computing bid price. Company may satisfy its doubts by clarifications obtained and conduct meetings in series with bidder for clearly understanding capacity and consistency that bidder has submitted for consideration. Company may also intend to deliberate with bidder about alternate bid submitted by bidder or try to extract from that degree of value. Engineering applied on original bid to work out alternative. In case company evaluates that alternative bid is certainly better than original bid, it may approve alternate bid for execution. Or else company would exclusively consider only original bid for purpose of concluding bid to status of EPC contract. After conducting many meetings for complete negotiations with all responsible discipline leaders and all resolution of contract matter, an award by company to bidder may be tracked in. Company communicates to bidder about finalization of bids subject to certain conditions based on technical corrections that should be fulfilled by bidder in a defined duration. Contractor works out and submits responsive details or receives bid price or content or BOQ item rates depending upon query raised by company. Contractor also works out what is specifically required for clarity by company. Relevant documents are submitted for further review by company. Company may demand performance bond or required sum from contractor per bid conditions. Once company is fully satisfied with bid and capability exhibited by bidder, company would issue an appointment letter to bidder designating it as EPC prime contract with given scope of work. The date would be affixed on this intent letter for EPC contractor designate to enter into a contract agreement with company in a company for bid project, and date of commencement of project execution is fixed immediately. Company instructs to contact given coordinates with company appointed engineer for EPC contract administration management and deal with such authority accordingly for further execution of EPC contract. EPC contractor is instructed to propose mobilization plan for approval and mobilize site temporary infrastructure and camp infrastructure for contract conditions and plans included within contract. Later, a kick-off meeting is conducted between company and all its leaders and EPC contractor and all its leaders for further follow-up project by both parties to EPC contract. Post award of EPC contract, company prime responsibility and obligations are to push surveillance and control all operations conducted by EPC contractor. Company has to press contractor to submit its master schedule or level 1 schedule within 14 days of contract commencement day. Further level schedules up to level 5 to be submitted to company in stages as defined or agreed. Company has to company has to press contractor to submit 21 days to 90 days look ahead schedule on a weekly basis so that progress monitoring may be effected with successfully. Company has to press contractor to make all submissions in scheduled time. Company has to insist contractor to award soil investigation and geographical investigation activities, operations, vendor services, subcontracts without wasting any single day. Since these investigations will support all foundation activities adversely or progressively. Company has to fix various meetings such as weekly, monthly, quarterly, etc. depending on to work's progress on site and also progress on design, engineering and design office. EPC contractor designs. It's a parallel activity that should be conducted by contractor without contractor with using its in-house design division or using its alliance for design. All feedback is provided to alliance partners, engineers with complete necessary contract documents. In general, designers in alliance are considered lead partners on EPC contracts. All designs and post-design clarifications are obtained from them as work, technical or engineering clarifications and instructions. Designers carry out complete designs related to all engineering activity on contract project. Designers submit to company engineer all designs for approval and then distribute accordingly to all related offices such as execution office and company engineer's office and elsewhere if so required. All revisions on designs are made by alliance design engineers throughout currency of contract. All site queries are responded by designers. Continuous interaction is affected between designers located wherever on globe and site design engineers through contract currency and even for submission drawings at closure of project. All changes made on site are conducted under approval from designers and accordingly red lines are marked on such changes, which are incorporated into as-built drawings for purpose of future reference during plant maintenance. Designers all day Designers always keep in touch with company engineer for various purposes of designs and also for various purposes to select vessels and equipment related to project process trains and related foundations. Such professional interaction between EPC designers and company engineer is very significant for progress on contract project. What happens in certain cases, the designs are altered at 11th hour of pouring concrete due to alteration on designs related to vessels and equipment. Even though pouring state was prepared and ready for pour, work is stopped temporarily to make changes on site works and then pouring is done on modified works in line meeting new design requirements, even though there would be certain delays on certain operations. Life camping preparation. Life camping preparation. A suitable camp layout is prepared for required number of residents including staff and workers, permission to be obtained from authorities and company to commence with camp construction. Camp, which is called life camp, may be located within a municipality or statutory authority demarcation limits. Preparation for this camp to be conducted in a professional manner. Camp must be provided healthy and suitable porta cabins types set of rooms provided with toilets and electricity along with air conditioners. Access to all rooms should be impeccable and circulation be free. No water from rain should stagnate in camping area. Reception gate guard room should be located at entry gate. Messing facilities should be provided depending on nationalities involved. Washing and laundry should be provided for all personnel. Common toilets and common bathing areas should be provided for workforce with continuous water supply. Water tankers should deliver water to camp overhead tanks and reservoirs at ground if so provided for. Recreation centers, common rooms with TV facilities should be provided for all workers and working staff. Adequate ground should be left open for games play purpose such as football, tennis, etc. Area should be left for buses parking, cars parking and equipment and machine parking. Fire prevention and suppression measures should be provided all along. A modern technology-based sewage treatment plant (STP) should be provided for full-time dedicated operation. Arrangements should be made for waste disposal, meeting environmental requirements and statutory regulations. All arrangements should be prepared for dust hazard prevention so that dust does not lift and fly into air. All precautions should be resorted to. All precautions should be resorted to prevent all other hazard mishap due to toxic materials. Areas should be demarked for assembly when emergency alarm is blown or budged. Messes should be provided with full level fire prevention and fire suppression equipment. Accommodation should be provided with fire extinguishing equipment. No accommodation should be allowed cooking facility. All persons have to depend on messing for purpose of food and breakfast all days during contract until workforce is demobilized to other sites. Site preparations, EPC contractor. A lot of commencement operations are required to be affected by EPC. You can say many operations by EPC contractor in very short span of time. Applying to obtain commencement work permit from operating authority in case it is requirement by law. Conducting site surveys and security fencing work. Conducting approval of soil investigation and geographical laboratory and award it to commence with its work. Applying to company engineer to select locations for drilling bore holes for investigation purpose. Submitting existing survey level profiles of all area within project boundary limits. Removal of all soft and clay soils from all areas, obtaining approval of soil samples for soil to be imported from burrow pits or elsewhere, obtaining soil samples for full range testing by laboratory, submission of test results including all etherbox limits, water content, voids, etc., carrying out granular graded fill to define ground levels in layers and compaction by heavy earth moving machines. Once all areas which would accommodate structures is filled and compacted to define profiles, site is ready to be termed as site preparation fill. Access road from camp to site must be made good and pliable with slow speed. Access road from main road to site should also be made surfaced with bitmac for smooth flow of traffic with heavy duty requirements with axle load up to 10 to 20 tons. Access road to site from camp, if not surfaced, should be kept watered weekly to prevent dust hazard. Site offices installations. Company offices for its engineers and supporting staff be provided with complete furnishing and sanitary and water supply facilities. Adequate conference area and rest area should be allowed on these offices. These should have reception counters, document control area, supporting engineer's office, kitchen, etc. Adequate car parking shed should be provided for desired number of cars. All required other furniture and special services should be provided in designated room. Administrative support staff should be regularly provided if it's a condition within contract. Beverages and refreshment should be allowed to these offices if its requirement is constituted within contract scope. Components on such plant facility project. Sit down sit down for a while. Process area. I'm talking of components on such plant facility project. Process area, non-process area, control area, electrical substations in all areas, administration area, warehousing, road network in all areas, utilities and underground services, external interconnections. Now, plant site comprises various components as listed below. Vessels, foundations duly housed in, equipment foundations duly protected, control building, operation buildings, electric substations, cathodic protections, critical and non-critical, centrally controlled remotely. Pipe racks for overhead run of process piping, administration building, amenities buildings, warehouse building, firefighting building, consumer research stations, gate houses with control entry, underground piping and utilities piping, electrical duct banks, seawater basin with pump house integrated, cooling water pipeline, source from shore, fire fighting pipe network all over plant area, underground piping crossings, overhead piping crossings, stormwater disposal system all over with catch basins and swale, oily water collection and disposal system, acid water collection and disposal system, electric cable networks underground and external interconnections, hard work and cold work, CCTV network, SCADA installation, instruments, pumping yard at sea, security fencing of various designs and classes depending on locations, roads on entire plant, street lights all over, concrete paving, landscape both soft and hard wherever required, direction signs all over in plant area, direction signs in buildings. These are limited one. There are so many which can be taken up. Just for your information, I have listed. Then a specific detail related to components. Buildings. Buildings located in process areas are designed as blast resistant structures with all RCC elements from foundation to roof slab, including structural walls. Blast doors are provided to all such buildings. Control building is provided with complete RCC envelope with just entries and exits. At least 2 hours fire resistance is provided to all such structures. Buildings located in non-process areas are designated as blast resilience structures with structures in RCC elements from foundation to roof slab. Walls are provided in concrete blocks, duly reinforced in and cavities filled in. Buildings located in all other areas not directly affected by explosion, direct or indirect effects are designed with normal parameters. Remind that from process area to more than 600-meter locations are blast free, while between 200 to 600 meter are blast resilient and up to 200 meter are blast resistant structures. Even fire vapor formation is always prone to blast area, which can lead to plant fire depending on air pressure buildup and temperature impacts. All electric substations are provided with fire walls, utilities and piping. Ductile iron pipes, concrete pipes, FRP, GRP pipes are required for main networks. For water supplies, for cooling plant equipment purposes, using seawater basin at intermediate locations from where water is supplied to plant areas and to which water is supplied from sea shore. A drinking water network is also provided in many plants that draw water from a specific source and distribute it to all areas on plant. Electrical duct bank embedding cable direct within concrete are provided. Electrical duct bank embedding cable ducts within concrete are provided all over cabling areas around plant, which carry all cables required on plant use and duly interconnected to main power cables, feeders. Plant is given network. Plant is given a network of all underground services in various orders, which is complicated one, but clashes are avoided at all levels. It has been seen that many hundred manholes are installed on certain plant for underground services use. Swale is provided on the entire site, running at roads, bumps, catching rainwater from all over plant area and thereafter conveying to a conveying to an open reservoir called lagoon and also transported to outfall chamber if so designed. Design profiles, design specific. Let me see, time management also important for this. How much time I have? So it is 2:46, so we have time. Okay, let me continue, no problem. Designs specific, and pages are many, 72, okay. Excavated trenches are prepared for blinding. Excavated trenches are prepared for blinding. Blinding receives RCC foundations such as independent footings, combined footings, strip footings, rafts, massive concrete blocks for various types of structures. All foundations are provided with concrete protection horizontally and vertically below ground. All portions above ground all portions above ground are provided with above ground concrete surface protection. Protection board is provided to membranes below ground levels. Various types of soil Various types of soil fill are provided such as engineered fill, structural fill, general fill, sand fill, etc. Graded slabs are provided to buildings ground level without cellar or basement. Ground level means plinth level also. Buildings are provided with structural framing covering all levels. In some buildings, structural steel structure is provided, such as stores, garage, etc., with sometimes floor in RCC and other structural steel framing, but all foundations in RCC. Vessels foundations are provided with heavy foundation, keeping minimum size of member more than 800 mm. Rotating compressors are provided on tabletop foundations, which is a heavy structure with massive substructure block, thick columns with steel marriage inserts and thick tabletop. Substructure massive foundation is poured in one go, treated with thermal curing method. Formwork is removed only days after which curing period is over. Annular space between compressor base plate and tabletop surface is grouted with epoxy based mortar since it is a rotating equipment. Annular space between stationary equipment, base plate and foundation surface is grouted with cement based chemical mortar since it is a stationary equipment. Tabletop is housed in a structural steel building with profiled sheeting roof. No roofing laid by torch applications is permissible. All structures, no roofing laid by torch application is permissible. You cannot use torch in such areas. All structures are provided wind resistance to a magnitude of 160 km per hour. Wind flow considered. Okay. All structures are provided with resistance to a magnitude 160 km per hour. Wind flow considered at a height of 10 meters from ground. Fire consideration should be made very wisely to avoid collapse, since during fire hazards at more than 500 degrees Celsius, concrete starts losing its strength, to resist which reduced sections work concept must be applied in designs according to European codes. Street lights, generally 12 meter and 18-meter high, are installed, which required at least 1 meter by 1 meter by 1 meter sorry, size of foundation with PVC duct embedded in concrete. Sorry. Street lights, generally 12-meter and 18-meter high poles, are installed, which require at least 1 meter by 1 meter by 1 meter size of foundation with PVC duct embedded in concrete. Firefighting is considered a very significant installation since it protects plants from its hazards. Its pressurized network is required around whole process areas in form of closed rings. Areas which are able to be sealed internally. Energen gas system is provided indoors. Assembly areas are marked all over plant for purpose of head count. Assembly areas mean external areas, not in buildings. Assembly areas are marked all over plant for purpose of head count and evacuation during fire emergency. Computer rooms areas are provided with raised flooring system, particularly in control building. Raised flooring system. Computer rooms areas are provided with raised flooring system, particularly in control building. No problem. Site team. Site team comprises of construction related personnel under leadership of construction and project managers. Method statements are prepared for each activity or operation in details for purpose of review by quality division, thereafter by project manager, and finally by company. Project manager of EPC must ensure that all construction method statements are prepared and approved much ahead of carrying out respective activity operation so as no delay is caused to project. Method statement should give complete direction to all those who are responsible for carrying out works and those who would vary and surveillance, who would verify and surveillance all well those as well those. Method statement should give complete direction to all those who are responsible for carrying out works and those who would verify and surveillance as well those who would ensure safety arrangements being intact. No work is allowed for prosecution in absence of related method statements. On projects as such, there could be many hundred method statements for which a list should be prepared by EPC project manager for purpose of appraisal by company so that unnecessary statements are not proposed for approval. Where repetitions are involved for activities, Quality Division must have prepared its inspection documents in advance and have them approved by company so as not to contribute to time wastage. Similarly, safety team must have produced its methods as well as its safety plan for various significant and general operations for approval by company. All works are done in conformance to designs, specifications, and in line to approved method statements, as well as direction provided by manufacturer of product. All verifications on inspections are proposed by site team to quality personnel for approval and for further approval by company. No work should be carried out without inspections for which inspection is required according to agreed procedures. In case of non-conformance, NCR, to procedures or to failure adhering to specifications, non-conformance reports are issued by quality managers requiring remedial measures, proposals by site team. Site team then submits its remedial proposal, which is carried out after being approved by company engineer. Once inspection is effected with on remedial measures, non-conformation report is closed. Inspections should be done for all disciplines in line to coded provisions as well as set procedures or per agreed methods statements related to quality part. All pipelines laid required testing and specific per specifications and therefore should not be backfilled around and without completion of required testing in first place or first fix. All foundations should be inspected finally prior to being backfilled and recorded as inspection of completed from foundations. All materials are to be included permanently on works should be sent for testing in accordance with demand in specifications and reports submitted by project managers to company engineer. Testing related to all materials whatsoever in all disciplines should be conducted in accordance to specification requirements. All suspended slabs should be allowed centering and shuttering in compliance to manufacturer's design of formwork supporting system, which must be on drawings considering into calculations all structural parameters such as shear force and bending moments and deflections. This drawing is produced by a third party who supplies supporting system and would inspect as third party site works of supports for support fitness certification, authenticating concrete pour above support, but this certification is applicable to system fitness only. I repeat this important significant step. This drawing is produced by a third party who supplies supporting system and will inspect as third party site work of supports for support fitness certification, authenticating concrete pour above support, but this certification is applicable to system fitness only. Similarly, all drawings are produced for all heavy element formworks by a third party and certification obtained as aforesaid. All scaffolding used for RCC elements related works should be structural scaffold and not otherwise. All equipment used on site works should be duly calibrated and perfectly in working order. While preference should be given to electrical operated machines, all hoisting equipment such as mobile cranes must be third party certified and duly valid on days of working. All precautions are required to be complied with while operating such equipment. No man should be allowed to use crane buckets for vertical movement. Concrete batching plant should be checked regularly for calibration and co-related calibration. Concrete batching plant should be checked regularly for calibration and corrected corrected to if so required frequently. All equipment operatives should have valid license for machine one operates or they operate. When work is carried out on public roads for interconnections, required permit should be obtained from area opening authority. This application for permit requires scheme or plan for traffic diversion during excavation work to go on road crossing which road crossing should be carried out in line to permit conditions and road crossing should be carried out in line to permit conditions and traffic diversions method statements. All electrical works of each fix should be conducted by trained and licensed electricians only. All HVAC works should be carried out by duly trained and experienced technicians. HVAC and electrical activities should be carried out in such a way that no clashes between two disciplines as well as with other disciplines should affect by conducting an early coordination among all disciplines, coordination and interface among all disciplines. Brief list of method statements may be enlisted as follows. I'm just giving a reference. Excavation in trenches in soft soil, excavation in hard soil, excavation for raft foundation, excavation in deep foundation areas such as compressors foundations, excavation for basement and underground structures such as sumps, piling in foundations, blinding concrete, foundations in all cases, application of concrete protection, waterproofing below and above ground, backfill all types of foundations and underfloors, grade slab work of RCC slab, RCC columns and RCC walls, RCC suspended slabs with down stand beams, concrete block work, plaster and rendering, roofing system, flooring and tiles, marble fixing on walls and floors, raised flooring, dry lining in gypsum and in cement board, suspended ceiling, various classes. Various classes, internal and external paint, GRC works, road works, precast manholes, laying pipelines, all types, road crossings, pipe racks and pipe rack crossings, laying deep GRP pipes, laying deep GRP pipes, works related to substations, work of electrical pole foundations, works of structural steel fabrication in and erection, structural steel painting, structural steel decking floors, works of epoxy flooring, RCC buildings in blast areas, works of epoxy flooring, RCC buildings in blast areas, landscape works, central control building of complete RCC quality system list for inspection. Then quality system list for inspection, it is after central control building of complete RCC, then quality system list for inspection. This is, I'll speak to you and please. Sorry. Okay, what is the problem? Wait a minute. Its quality system is this Inspections we have to make and means excavations. This is an element, activity, excavation, inspection we have to make, quality system list for inspection. Excavations, blinding concrete, foundations with formwork and reinforcement, waterproofing below and above ground, which is soil protection of concrete, backfill all type of backfills, RCC columns and walls, RCC suspended slabs, pipelines all types, all services, roofing, structural steel works, all types of finishes, all types of floorings, roads and landscaping. Foregoing list is just for information with no reservations. All statements and inspections should be conducted per work requirements only. Operations got no limits, which depends on project requirements and degree of accuracy applied. All changes made on site. All changes made on site. Works deviating from drawings with former approval should be recorded. Red lines and contract documents updated accordingly for granting as-built status. Whatever changes are approved on whatever document or specifications of else should be recorded as red line for as-built conversions. At works completion of whatever area, all documents are prepared. What I said, at works completion of whatever areas, all documents are prepared as built for submission to company as dossiers. Pre-commissioning should be commenced with by joint inspection by all leaders from all disciplines. Punch list should be prepared and notified for corrective actions and after circumstances, after corrective questions are made, punch list is cleared. Let me repeat. Punch list should be prepared and notified for correct conversion. Okay. Punch list should be prepared and notified for corrective actions, and after corrections are made, punch list is cleared. All documents related to works quantity, quality, approvals, and other records should be submitted as dossiers to company engineer meeting contract requirements. Similarly, all areas should be closed with dossiers for purpose of performance, testing, and commissioning. Performance, testing, and commissioning is effective for whole plant, and if for duration of specified testing remains successful, approval is granted or else retesting is done for performance. Once all checks and performance testing is completed, mechanical completion certificate for related areas or for whole plant can be released for something or released for company. Once all checks and performance testing is completed, mechanical completion certificate for related area or for whole plant can be released by company engineer. Once mechanical completion is granted, maintenance period defect liability period commences with. Once mechanical completion is granted, maintenance period defect liability period commences with immediately post date of mechanical completion. Now, this was activities for quality. You'll have a talk later on also on this. I am jumping over to clause 9, this performance evaluation. Clause 9, performance evaluation, which is also very important part of management. It does with very important part of management it does with and is to be taken care of. Performance evaluation. It says it should include monitoring, measurement, analysis, and evaluation, internal audit, management review. Let's consider in this what are points for consideration. Let's assume what are points for consideration, for example. Monitoring, measurement, analysis, and evaluation, internal audit, management review, and points consideration are management requires to decide about internal audit to ensure compliance of management system, final review by management to ensure its compliance, and whether or not the system works suitably, adequately, and effectively. Construction operations are monitorable and construction operations are monitorable and measurable for purpose of further analysis and an evaluation. EPC project is a complex process to deal with performance measurement and evaluation. Measurement Measurement is conducted for all divisions such as designs, procurement, planning, quality, execution, etc. in all respects. Monitoring, measurement, analysis, and evaluation is a detailed, defined process. Is a defined process. Measurement is whatever. Let me repeat this. Some missing here. Construction operations are monitorable and measurable for purpose of further analysis and evaluation. EPC project is a complex process to deal with performance measurement and evaluation. Measurement is conducted for all divisions such as designs, procurement, planning, qualities, execution, etc. in all respects. Monitoring, measurement, analysis, and evaluation is a defined process. It's defined means monitoring, measurement, and analysis. Evaluation is a defined process which requires to be conducted both by internally and internally monitoring, measurement, analysis, and evaluation is a defined process which requires to be conducted both by internally deployed management as well as at defined schedules by external third party audit authorities. From time to time, at defined intervals by internal division, by sometimes you miss lines because it is single line. Well, from time to time at defined intervals by internal divisions of quality and external agencies which submit respective observations which are complied with in all regards and future course on quality modification is affected with. Foregoing described observations recorded by both instructions should be entirely reviewed by top management leaders. Top leaders then requires to decide degree of compliance of current system and what steps should be required to be taken to make it fully compliant, and also what degree of value engineering can be inducted onto existing existing system for further successful competitions. Whatever system is followed should be maintained and upgraded according to evolved new requirements, which be conducted without any constraints and upgradation affected as and when necessary. Affected as and when necessary. Clause number 10, that is improvement, which includes non-conformity and corrective action, continual improvement, and points for considerations are as stated in changing business environment, processes and objectives vary, to meet which requirements continual monitoring, evaluation, and improvements are a must. As stated earlier, that technologies keep on changing as well as business environment, which makes it incumbent upon organization to keep pace with market so as to be at required standard mark, which this requires review of non-conformities, resorting to corrective actions for charting out corrective actions. Such making and evolving keeps system frequently updated, and all involved personnel continue, learn and update. Lessons, certain lessons. It's not conclusive, just informative. All leaders require shared improvement responsibilities all times at currently running projects and adopt as lessons learned on future projects as past or historical references. All mistakes, all mistakes, defects, and non-compliances should be freely recorded without any hesitation and notified all such learning to all key personnel and leaders to adopt these lessons on future operations as references. Research should be made or done on all such operations to understand various ways to further avoid repetitions related to such works, errors, and oversights. Now, certain documents which are very important should be considered here. These documents are of significance that we must have an understanding about, and these are EPC contract documents, EPC contract documents, company instructive documents, company organization chart, company directives, company's standard specifications and designs, EPC project schedule agreed with company's engineer owner, EPC contract drawings, EPC contract specifications, EPC execution method statement, significant method statements, shop and working drawings, national codes all disciplines, international codes all disciplines, national annexes all related to codes, nationally determined parameters all related to codes, published documents all related to codes and requirements, DAB if applies when details of procedures and members on panel and visit, schedule for hearing or for general inspections. Other significant policy documents form company and from documents from company and from EPC organization, records of lessons learned by EPC contractor from past works, records of lessons learned by company from past works. This is not complete list but for information, and let us see one by one what actually these are. We have to understand EPC contract document first. That can be understood only by what means EPC is. EPC is abbreviated form for full form is engineering, procurement and construction. Everybody knows this. What are those documents? EPC, from where does it come? EPC is for project, and that project has come from some backing, and that backing is FEED, 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 front end engineering design, and that has also some backing, and that is feasibility report, and that has some backing, that national policy, because there is some national policy or some state policy which requires certain development. That has led from that initial conception to a state of project that we are designating EPC. Means we are not able to do it ourselves as government body or as private body. We want to give it to some other person who is an expert in designs and in construction, or either of these in alliance with some other party. So that person, that company, that organization would work for us as a package contractor of design, construction, procurement, etc. for this project. That is EPC. Means that person is going to, based on feed information, design for us and execute for us in every respect of disciplines of engineering, civil, electrical, mechanical, CCTV, security, IT, and all equipment and trains processes, whatever is included on that plant shall be managed by this contractor, professional contractor, It is called EPC contract. Documents means based on this contract, there are two party. One party is this one, which is giving this contract called employer, or we call it in contract language company or engineer. We are calling company in this contract of facility. So this company and another company organization, that is contracting company, EPC contracting company, this company which is giving job is employer, and this organization which is taking that job, that is contractor. This company is party 1, contractor is party 2. These both have certain agreements now, contract agreements for EPC. There's a need, there's a requirement by this company, EPC by this company, and there's a requirement to take this job and do this job and do by contractor. They would have certain documentation on agreement. This is our agreement. Whatever lump sum fixed price or different type, generally lump sum fixed price works on such contract, a major one, and there are all disciplines involved, and whatever are they perfect for they will do, and in which they are not perfect they would sublet it to someone else, subject to confirmation of approval by company. This is there are thousands of documents for this project based on such feed. Feed itself is very expendable document which contains lots of technical policies requirement and other requirements, and surveys might have been done long back. Those surveys must be a part of this geographical survey or geotechnical survey, whatever could have been done, all must be part of the history of this project should be there. Like that, this is explanation. Then company instructive documents. What company says in what this organization of employers says you have to work like this. These are instructions, these are philosophy that we follow. We want you to convert based on this philosophy. You are designed and implemented accordingly. There are various documents, technical documents, engineering documents, design documents, specification documents, and many more procedures and all that, and what they are. And then company organization chart means employer complete organization, what they are, total hierarchy of them from top to bottom, for purpose of contractor to understand how to deal with them, how to coordinate with them, how to have counter and non, means how to those officers and these officers encountering each other for positive results, interfacing each other, and you can say coordinating with each other. Then there's company directives, means what company wants to tell contractor, you have to follow this, you have to deal like this, you have to manage with us like that. That is very long document. And then company just standard specifications and design, as I just explained in other point. Company has certain specifications, that is general specifications or specific standards or designs or diagrams or whatever, or process flow or whatever they want you to do. Those documents are involved. In major documents, you can say these documents are like mandatory documents. And then EPC project schedule. EPC project schedule agreed with companies, engineers, owner. That is now not companies, that is a proposal given by contractor, which is EPC. That project schedule or program or bar chart or CPM or whatever it is, that shall be agreed with this company, between this company and EPC, and that is project schedule. Then contract drawings, EPC contract drawings. There will be drawings, EPC would submit those contract drawings. Then contract specification that EPC has to submit. Then EPC execution method statements, all that will part. Technical submission, these are all parts of technical submission that I'm talking about. EPC project schedule agreed company, contract drawings submitted by company, contract specifications that submitted by company, execution master statements submitted by company, all duly constitute technical submission where significant method statements also, that's very important part, can be submitted at that time or later on, but these constitute major documentation. There will be hundreds of method statements could be possibly on such a major project of EPC facilities, and then there will be shop and working drawings which will be thousands in number during currency of project starting in which year start, and then there will be national codes all shipments in whichever country you're working, those national codes as well as internal codes, all disciplines. International codes can be American codes, can be British codes, can be European codes, can be just some other codes which can apply to that project. And then there were national annexes, all related to codes. National annexes means this is EU requirement across European Union codes. Whatever codes are there, they have standard specifications, fixed writings, but there is something to those areas where work will be done, which they do not know, EU do not know. In whatever country you are working, you have to comply with those national annexes, which are variables in those codes. Then nationally determined parameters all related to codes. It is also same thing that every country has some definite changes because of so many reasons regarding environment or regarding seismic action or regarding something else which they will give you just the brief. These are changes, though it's not brief, it is whatever it is, but that is also a part of major document. Then national annexes, nationally determined parameters, now published documents all related to codes and requirements. Codes and requirements we have, those documents must be made available or when required made available. Then published documents and all related codes. Then it is DAB. DAB if applies with details of procedures and members on panel and visit schedules for hearing or for general inspections. Disputes. DAB stand for Dispute Adjudication Board, which is an institution or which is a panel exists between engineer and formal arbitration body or panel. DAB if applies with details of procedures and members on panel and visit schedule for hearing or for general inspection. Now, other significant policy documents from company and from EPC organization. So that is normal means other significant policy documents you have to submit. Then records of lessons learned by EPC contractor from last Turkey. It is actually very important submission. Very significant submission it is. Then lessons learned, whatever you learned on that project, you have a record of that. You try to apply that, simplify that, but it doesn't practically happen. But what I do is the international requirement. International requirement has to be complied with. You cannot say no. So lessons learned is also international requirement. What did you learn by mistakes? Why there was mistake? What you have done to avoid those mistakes? Everything must be given. And then this is your your records of lessons learned by company from past works. All that must be given, and this is actually very important aspect of life in such projects. What actually I was talking about, it's very interesting from point of view of such projects which may take which may take for granted sometimes, we don't extend to them, requires importance, requires significance because our lack of information or lack of understanding of such projects. Such projects actually are backbones of every economy or nation. All big projects, which you can call them facilities, this can be oil plants, this can be onshore refineries, this can be cracking units, this can be plastic you can say production or byproducts, you can say ethylene plant for example, alkali plant another example, or some powerhouse or some other type of industrial big unit which consumes, or you can say nuclear reactors or something like that, which can be classified into mega projects where thousands workers work for years and hundreds of equipment are installed and billions of dollars are spent, and desert is developed into industrial city, desert located at beaches, at you can say oil beaches or some other beaches from where there is expectation of industance of oil. While I have not seen my whole life up to now, but doesn't matter. These projects cost billions and billions, and develop these projects provide employment. This provides improvement to economy because you have to manufacture or import vessels, equipment, machines in hundreds numbers, which are very big number. You have to design and construct foundations, you have to prepare sites where millions of cubic meters of backfilling done, preparations are ready, and then foundations are done on that. You have to, you are located at sea because this is that type of project, and you have to provide all these infrastructure facilities that we have been talking about. Isn't that simple? It takes time on design, it takes time on bidding, it takes time on execution and prosecution, then maintenance, and before that commissioning and pre-commissioning. There's a lot in this. Of course, it's very interesting for those people who are real leaders in engineering or somewhere else. If we have to maintain ourselves, we have to keep it up. Such projects are very significant. These are located in remote areas, hundreds of kilometers from city areas, and those professionals and workers who are interested in such projects have to stay in those deserts or in forest areas. There's no other way because you have to work for at least 12 to 14 hours a day. It depends upon interest, particularly for those professionals and staff who are interested to learn something in life and to contribute their services to national development or international development. They have to stay there in somewhere live camps because camps are available there with controls, and you can stay in those camps according to your status, and you will get food also there because in desert you cannot cook your food, you have to depend upon food provided by that company who is APC. I also provide food for sometimes in daytime due to these people. I think not food, they provide to them some fruits or something. So that is enough for these people who just move on to get their people in. And once people are mobilized, that is called mobilization stage after tendering is over. This is very big activity. Hundreds of people are involved in offices, you know, people from company are involved, people from EPC contract are involved, people from subcontracts are involved, and before people of civil work contracts are involved, then people from vendors are involved, people of furnishing companies are involved, people from all areas are involved, and workers are involved. How many buses and cars are involved, how many vehicles are involved, what size of offices are involved, how many computers are involved, how many desks are involved, and how much communication is involved, how much trans communication is involved, how much movement is involved. All these constitute major exercise in profession and in trade, and isn't that easy as we take it. It's big area you have to walk around, which may be 1.5 to 2 kilometer length and 1 kilometer wide for such plants. And there are internal streets and roads, internal traffic controls, entry controls, and you may find nearby refineries which might be releasing certain chemicals, gases that can affect it. It may be LNG plant, it can be ethylene plant, it can be some other refinery, it can be alkaline plant, it can be anything. Means you are going to use byproducts which you got left remains from oil extraction from platforms are located off-shore to on-shore. You are on-shore and dealing with these plants, and you have to stay on such projects for years duration because these projects are tight, and you have to supervise to take care of big jobs all days and nights whenever required. You cannot run away because it's you are showing responsibility, you are sharing responsibility as a professional. You have to be there in that respect. Otherwise, there is no meaning if you just want to pass time. If you want to learn something, you have to devote, and such projects are itself in a big technological learning. They have their own processes, they have their technologies. They are promoting this technology so that it works. And these flow charts, which means all trains are connected, how many trains are there. Trains means these are located in process unit areas. Process unit areas may have actually dangerous areas, fire areas, blast areas, these are called. And in these buildings are also very strong, which are called blast resistant buildings. They're having many foundations, major foundations, massive footings are there, mass foundations are there, and concrete is also of different nature, which should take time in setting. We cannot pride OPC there or some there. Generally, GGBS replaced, cement replacing is used in this concrete. Even up to 70% of cement is replaced by GGBS. These units are such and require different treatments on by curing and different types of execution methods, continuous methods and fast concrete methods. Generally, the concrete is done at night or early morning because of reason of temperatures. So these projects consume lakhs and lakhs cubic meter of concrete sometimes, and you can say many thousand tons of structural steel and other materials. And then there are so many buildings involved in addition to trains of process areas. There are buildings such as central control building, such as administration building, the buildings such as substations and various other houses. They are in administration building, amenities building, and then these administration amenities warehouse buildings are generally located in non-process areas, whereas your process areas contain central control building and utilities deep in foundation in ground. After utility pipings, a lot utility pipes are there. There's gas pipe and this pipe and water pipe and so many piping, so much piping work because of rainwater disposal, oil water disposal, and oil disposal, acid disposal, many other disposals. And then certain off-sites building where substations are there, utility substation, main substation, many other substations, and many other areas are there. And then power stations from which they extract power for themselves. The internal loads are there, so much spread out. And of course work is not too much in height vertically, work spreads in horizontal movement, horizontal expensive areas are these. This very important point we must make an excellent understanding for this. If you cannot understand this, if you cannot imagine this, you can just go and see this type of projects from your Google Earth. If you can just search, you'll find many such sky photos from there, sky taken photo, and you see plants there. It's an interesting one. It's once buildings are also there. Of course, these are not high rise. These are one story or two story. Administration building is almost generally two stories. Ambulance building will be one story. There will be what in warehouses, and there will be, you can say, water containing sea basin there, seawater basin, which is also very big one. Then there are foundations of compressors, which are massive blocks and very interesting to see them, their design and their execution. And there are so many other points, and to work on technical examination like reviewing drawings and finding, you can say, incomplete somewhere in all drawings. Then you have to raise query based on that smartness. You have to see all that, and you have to design all internal manholes, which is also a big exercise. There may be many hundred internal manholes, and you have to design one by one. You cannot take a typical construction because there are so many inlet pipes coming in and outlets going out. So many elevations are there, and so you have to design sizes and depth of all and inserts for those pipe and precast them for precasting purpose. You have to produce shop drawings, working drawings in all elevations internally and plans, and then which pipe is coming, which is going out, and then this precasting units to be lifted and transported to various locations, and then you have to cast in site work which is of other chambers, and which may be your these big units to be casted and other units to be casted, which on-site work works. And so there are so many, possibilities on such projects, which really makes something for you. You cannot run away from that project once you start working there. Of course, these are not like other buildings. These are ordinary buildings, but these are RCC buildings. For example, Central Control Building is RCC building. Many many substations, or you can say main substation, which are located within process area, or for which are in isolation of that, these would be RCC structure which are required, and maybe many other one. You will find different types of designs. There will be reservoir type lagoons, big area lagoon, where all discharges come into, and from there it's taken to further disposal to see through other outfall chambers. And when we are taking water for purpose of recirculation of these plants, we have to bail water from sea, and that sea is nearby somewhere, from where you have to transport this water through underground piping, or that is big pipes, where you can say to take millions of cubic meters of water. You have to use big pipes on through from sea by pumping to this location of at somewhere nearby this plant, and from there you can pump it further after some filters or something to this complete plant, which projects, which buildings require. There is a process ongoing. It's because it's industry, so you have to allow your industrial health to such projects on computers, and then you have to see all that internet capabilities, interconnectivities available. When it's a kind of complete professional work, that pipe which comes from sea goes to reservoir or seawater basin. It's a deep one, expansion joint, construction joint, pump house, big walls, completely RCC containment, RCC bases, RCC walls, RCC, you can say, pump chamber, from which you have to supply that pipe volume water to all this processing plant, and then circulate again and take it out and dispose it. This is continuous process, and there's firefighting link outside, spread throughout the processing area, others just to contain, just to suppress fire in case it breaks out. It's very interesting, and kilometers and kilometers of roads all around internal roads, for which, because that road is very complicated, hundreds and hundreds of services are coming there, and there are external connections, and there's gatehouse, and then you can say there are customer receipts receipt sections, and so much is there. And heavy traffic too shall be accepted because this is industrial project. You have to take care of that into your consideration. It's a big deal means if you are professional there, even in office engineering position, or a site engineer, or as construction manager, or something else from EPC, or from company and or from even subcontractor, you will have an exposure to learn more and more specifications, methods, how to deal with people, how to manage your engineering, how to manage your construction. All that you will have an opportunity to understand if you join, irrespective of what salary you get. I suggest this such opportunity if you get. I was lucky to work there for 2 or 3 years. I think at that time, total 4 years I worked on such projects just to learn what I could do. Of course, it's not like learning on some building project, RC building, high rise or some other. It's different type of work, but technology is different. Different sorts of chemicals, different types of concrete, different methods. So many alterations are there. You know something. For example, you know what is thermal curing, what is different type of curing. It's not flooding all time. How you compact and how to prepare your site, how to do work in that. So much you can expose yourself to technical input that is very significant for engineers, low profile engineers like me, means where practical work teaches you, where your site is your teacher, site is your university, more significant that university from where you qualified your degrees or post graduations. Here you learn a lot, you draw a lot, you read a lot, you write a lot, you submit a lot, you are beaten and then you learn, then you teach others. This happens both ways because you are a learner and you are a teacher also. You'll find different types of people, different types of activities, different types of acts, and different nationalities as well, different types of design engineers, different types of working engineers, different sorts of foremen. All that is actually very important on such projects, which we must understand to expose ourselves so that we know what is national work, what is international work, what is European Union specifications, what are American specifications, what are UK specifications, and where do we stand, what does documents say, what designer thinks, how do they write, what's this language standard, how complicated are these services, how can we combine them, because there are thousands of trying and big size tryings. You cannot correlate them at once. For that, you need some concept. You need to comprehend that project as a whole. Only then you can do something. So you can understand that. You can do some research work on that. Otherwise, it's no meaning just to learn building alone. It is also a different kind of building, a different work where services are involved, where of course light road are involved, where buildings are involved, where foundations are involved, where overheads are involved, where machineries are involved, grouting is involved, waterproof painting is involved, while you can say fireproofing is involved. So many disciplines are involved there on such projects. This type of projects you get maybe once in your lifetime, or if you are lucky you may get again and again. But learning is important. You may be there for years, and if you don't learn anything, just think I have to take salary and pass my time. Of course you can maintain you there, but specialization is achieved only when you involve yourself there. That's very important point. Otherwise you just are a time passer and nothing else. And it's very significant talk. I try to make it. I can continue this later on for other similar talks, other similar methods that are very important for me to explain. And because the world is changing, we may have to face same thing here again in future. Therefore, I'm saying I'm going to close this talk today. Of course, I hope that those who come here to see this video later on, I know it is Sunday today, people are sleeping, no problem, later on they can see. But this talk was significant. Thank you very much for this talk, and thanks a lot indeed.